Hey guys, welcome to another code review video. I'm doing this one on the boss battle challenge, The Door, which is in the catacombs of the class. And I want to go through this one just because I think it has some interesting challenges in it. What's interesting, so this code is code that a reader had submitted. I think it's a really good starting point. Um, but I will come down here to the door class. I've had a bunch of readers in the last little bit post door classes that like did a whole lot of stuff, and this one, and I might have done a review with one that did a whole lot of stuff. This one's the opposite, where the door class isn't doing a whole lot. And this is the type of like design question that comes up a lot. Is like, where do I draw the boundaries between classes? How do I know what should go into a class and what should stay out of a class? Or when do I split this off into another class, right? So I kind of want to talk about that in this, and so that's why I decided to pick this one up. And I'm not going to spend too much time here, but I am going to spend a little bit of time. The first thing I want to say is I'm going to just do a little bit of cleanup here, which is something that I usually do, even not just for these code reviews, but just in all the code that I touch. Like I go through it and I'm like, okay, this can change, all these little easy things. I tend to start there because it helps me familiarize myself with the code, and it just makes the code a little cleaner, a little easier to work with. So I'm going to start with like says it's not used at all. I don't think this is unreasonable. Like when you think about, again, when you're thinking about class design, it is useful to stop and think about like even though I only need to use it in this one particular way, how might it be used? And so this person has thought a little ahead and said, I think I might want a parameterless one that starts in the locked state. You can see here this is marking it as having 0 references. So I'm just going to delete that. Oops. I'm also going to put a public on these. I think that my take is this isn't a place to like leave off a thing. It's useful to be explicit about what accessibility level you mean for these things. You certainly don't need to do that. And then this also has a bunch of methods that are kind of nested in here. I think what I'm going to do, and this is like I guess there's a couple of options here, and one of them is I actually prefer top level statements. Not everybody does, but it's a lot of just clutter here that isn't really justified in this small of a program. But I think I'm going to keep it in here just because the person had already done that. But what I am going to do is do some of this other clean up, and this is going to tell me to use a file scope namespace. The book, at this point, the book has not talked about namespaces at all. So like normally I would just say don't even have that in there. The other thing I'm going to do is, okay, good. Those are already here at the top level. Well, top level, these are the way this is defined now. They're in the door namespace. But then the other thing I'm going to do here is, honestly, if I'm using, I also will typically make that explicitly public, even though it's not needed. I'm going to delete that as well. You don't need the R's, but they're fine. I guess I go both ways on that. Anyway, these methods here, if I am using an explicit like program.main like this is, I don't usually use nested like a local functions. I will usually just scoot these out and stick them down here. And now they are, I'm going to make them private static. Got to spell it right. I don't want to spend too much time here on this, but I do, just looking at it, like this is, again, this try parse. The book hasn't covered it yet, and I tell readers all the time, when you're at this part in the book, halfway through it, don't get too concerned about user input. And you'll hear plenty of other smart people tell you the opposite of that. Oh, you got to worry about bad user input. Like your program will crash if you don't have good user input. And they're not wrong about that, with the catch being like there's the only user here is you. And right now the important things are about learning how to make classes and to like use a class, and the user input is fluff that's a little bit I don't know, it's a separate concern that is unrelated to what we're really trying to deal with here. So anyway, just zooming in, focusing on the input. We don't want to ignore user input totally, but we don't have to get it right. Anyway, this isn't one of those advanced tools the book hasn't talked about yet, but it does allow you to safely do this. If the user enters in a non-int value, this won't crash. So that's why this person's done it. It's fine. Like if you know how to use these tools, go ahead and use them, but don't feel like you need to know how to do this yourself if that's weird to you. The one thing that I am going to rework this a little bit. Like I think like this is going to say like I can just declare this in here, so I can just say bool response. I think. Oh nope, I'm actually going to make this just be while true. And then what I'm going to do here is I'm just going to say, so try parse. So if that worked, return to return. In all other cases, we know they failed to enter in something good. And oh, oops. So yeah, just rearranging this a little bit, and I'm just going to declare this inline here. Again, these output parameters are the reason why I haven't discussed try parse yet. Again, it's one of those things where I feel like if you don't know how to use them well, like if you don't know how to use them, it's better to just skip it for the short term than it is to use something that you really like. It's a little bit like, and you're not going to actually hurt yourself like you would with a chainsaw. It's a little bit like pulling out a chainsaw and trying to use it when you're comfortable using something simpler, a handsaw or something. Don't bite off more than you can chew. The user input tools like this we'll cover later. But so anyway, if you know how to use it, go for it. If you don't worry about it. I'm also going to just make this a while true because having to do while like that it's just a little bit more code. Not bad, but anyway. So there we go. So I guess I got to fix this too. Let's see how to do this. So the only issue that we have here is that because this used to be a local function defined in here, it had access to this variable, and now it doesn't. But like we're not using it at all, so I actually could just move this right into here. In fact, at that point, why not just make that my main method? So there, I've removed parts that, it simplifies the code. Whether that was the right thing to do or not is a different question. All right, so now everything compiles again. Everything should work like it did. And let's get into, so the main thing here is the stored class, it has a property for the current state, and this is this enumeration, so it can be open, close, open, closed, or locked. I'm going to rename these because so there's the, and I don't even know what an adjective like this. There's a description of the state: opened, closed, locked. And I'm being a little bit nitpicky. So like again, this is part of this. There's for a lot of people, and I'm not saying that the person who wrote this is in this category or not. It's irrelevant. Some of this is like a language thing sometimes for people. But it is pretty conventional in C# for these things to be like, I'm describing the state of the door. So rather than use a verb like open and close and lock, I'm going to, because I'm describing the actual current state, I'm going to use opened, closed, and locked. And I'm just going to, there's a shortcut in here. Refactor, rename, Control R, Control R. And I'm just going to rename it to opened. That describes the current state. And same with this. Now, if I also had an enumeration for the actions that you could take, like open, close, lock, unlock, then I would make. Then you could have another enumeration, like actions, and then have like open, close, lock, unlock. Like you, that could be legitimate. I'm not saying that all enumerations should be phrased like this. It depends on what it is, but the important thing is it's that consistency. So I've created that consistency in a way that I'm happy with. So now this is the current door state. It's one of these three options. And the catch here is that there's not like this class isn't really doing anything to protect its own data, which can be okay if there's no logic that needs to be enforced here. Then that's fine. Like if you have, for example, not that this is the best example, but if you have public class point and you have, public double x get set, and like, so you want it to be mutable, you want it to be changeable, and all double values are considered valid for x and y, then that is all you really need. Like you don't need anything else. But in this specific case, the door class does in fact have logic, and it's all of this stuff up here that like I only want to transition from locked to closed if somebody provides the passcode. I only want to transition from closed to open. I only want to go to the open again. I don't want to jump straight from locked to open or from open to locked. Like I have to be in a specific state in order to get into a specific other state. From closed, I can get to both of the other states, but from open, I can't hop all the way to locked. I have to work through the workflow. I have to close it and then lock it, which again is maybe situation specific. Like why couldn't you just transition? Like why couldn't you just define it as and you go straight from an opened door to a locked door, from a locked door to an open door, as long as you provide the code? Maybe. So it depends on the specifics here. I'm going to I'm going to say that's how it should work, is that you can't just go straight from here to here, and this code up here does enforce that. If we're in the closed state, then handle it this way. If we're in the open state, do this. If we're in the locked state, handle it this way. But also the one other thing here is that this doesn't I feel like the passcode should be part of it, and it's not. It's just this extra variable right here. So what I want to start with is moving the passcode into the door itself. And so what I'm going to do is I'm just going to, I'm not going to make a property for it, but I am going to pass this in here and make an extra. I'm going to delete that variable that is and just move it. So now in its place, I'm going to have a private string passcode. In this case, now that it's a field, I'm going to make it underscore, and I'm going to, there, what it suggested. All right, so with that in here, I've broken a couple other places that we're using that local variable. We have this one, if passcode equals, so if what they entered is that, which actually now I think of it, this isn't used anywhere. Yeah, that's what it's saying. Local variable passcode input can be declared in inner scope. I'm actually going to move it down. There. So now it's just right here where it was being used. So now this says if the input equals the existing passcode. One, like, to kind of make it so I can take some baby steps here. One thing I could do here is I can just make a I can just make that publicly gettable and settable. And now I can do door.passcode. Oops, public. And same here. So door.passcode. And I think that's an improvement. That now this is, it has the passcode in here. It's like we can still change this any way we want, and anybody who has access to the door can change the passcode in any way that they want. Um, but that's, like I said, the code at this point compiles. So we've taken these baby steps, and again, this is one of those like broad design principles. When you're doing this type of work, this is called refactoring, where you're changing the structure of the code without changing any user visible functionality. The smaller steps that you can take, the better. People will sometimes end up in a like literally months long refactoring. I've seen it. I've done it. It's been me before. And sometimes there's things that just are so big that you can't just like break it down into little pieces. But often, in fact, I'm actually fairly convinced that with a little creativity and with being willing to spend a little more total time, everything can be broken down into little teeny steps. The advantage of those little teeny steps is you can stop whenever you want. And that's like from a software development standpoint, that is a big deal. Because if you're working on a thing, you're like, I got to change some of this, I got to do some refactoring, and it takes you 3 months to make that sort of change, there's a really, because refactoring doesn't provide value to anybody, there's a really high chance that 6 weeks into your 3 month refactoring, people are going to say, you know what, let's stop working on that. It's not important. We have to get done with this other stuff. We got a deadline coming up and we need to put that on hold. I was going to say drop it, but that's what happens. The actual effect is it gets dropped. Um, but what they say is we just need to we got to put it on hold for a little bit. We'll come back to it. There's always this promise of we'll come back to it. And then usually you don't. So you don't want to get halfway through a giant refactoring and then have to switch to something else. Being able to break it down into little teeny steps makes such a big difference, because no matter what, as long as you can make these steps that are good enough, you can always stop whatever in the middle of something and just be done there. Or you're at least never very far from being able to say, okay, give me, I can stop, but give me one more day to finish this up. Like I'm 6 weeks in. We know we have a lot more to do. Give me one more day to clean up some loose ends, and then we'll do that. But then you at least get credit for half of the cleanup, and that sometimes the getting through a chunk of it allows the rest of it to just kind of organically happen. So yeah, finding these little like stepping stones that you can do that are like, this still to me isn't ideal, because I don't really want just I don't want you to be able to change a passcode unless you're providing the old passcode. Anyway, that's where we're at. But so let me add that. So if I do public string passcode, if I say public um, void change passcode. Actually, you know what? I want to make this bool. I want to be able to return a success or failure. So string old code, string new code. And then we'll just say if passcode equals old code. Actually, let me, okay, I'll keep going. New passcode equals new code, right? And then we'll just say return true, that was successful, otherwise we'll return false. With that said, I actually want to flip the logic around, because I think that makes it cleaner in this. I mean, and that's what this is suggesting. Invert if statement to reduce nesting. So I'll just tell this to do it, and you'll see the change. So this says if it's not correct, just bail. And now I don't have that indentation here. So it's like an early and quick exit. So if they provide the wrong thing, just bail. Otherwise, now we just kind of, nothing's indented down here, and we'll just go on with life. So now I have this, and instead of this change passcode here, instead of making that settable, well, one thing I can do is I can make it a private set. And the one place that's using this, I would just say door.change passcode. And this is actually going to change behavior, because because this is structured a little bit different than they had done it. Like, so one thing about this is when they what they've set this up for is if you say lock it, you basically set the code at the time of locking it. It's kind of like a one time use code, and this isn't how like I had written the challenge in the book, but I'm good with this sort of either just like interpretation of that or misunderstanding of that, because I think that this is I think from a object design standpoint and using classes standpoint, it doesn't hurt anything there, and it's a useful paradigm, right? Like I said, that the in a hotel you go and you put your wallet or whatever your valuables into this safe, and then you enter in a code, and then it's locked, and then you enter in the code to get it back out again. Um, Based on that, maybe you shouldn't need to enter in the old passcode. But so maybe like the act of locking it is when we should lock it with a passcode. Anyway, uh, so uh, now like that, I can't just change the passcode willy nilly. Like the only way that you can change the passcode is right here by supplying the old one. Although I kind of cheated by just like the user doesn't have to provide the old passcode. I just grabbed the current passcode. So that's kind of like I said. This is a baby step. This is a this is a baby step down that like cleanup path, but it's kind of a weird one given the paradigm here. So let's see what we can do about that next. I think what I want to do on this is start to work away. Right now, this is just settable. What I want to do is add in methods for something like public void lock, right? So like you can lock the thing, but so in this case, what I want to do, like I'm going to keep this settable, but what I'm going to do is right now, let's see, right click on this and say find usages. So there are 5 usages of this. I want to work myself away from any of these. Well, let's see. This one's probably fine, right? I think that one's acceptable. But I guess I'm going to leave that in there for the moment. But I'm going to add in a new method, which just doesn't adding in something doesn't hurt anybody, right? It's just new code. So I'm going to add in a method to lock it. But in this case, this is where I'm going to say um, add in the code. So what I'll do is I'll say if this is already locked, sorry, this is if current is not store state dot closed, return, and possibly we could do the same thing here and return a bool. Maybe we'll go ahead and do that. Bool, come on, bool, return false. We didn't actually lock it, and then otherwise say current equals store state dot locked. So we do get locked, and passcode equals passcode. So if it was closed and we transition to the locked state, that line right there is why I might like. I don't think I'm actually even going to use those Boolean like success or failures when this is all done. So like if I just make this void, then it keeps my code a little simpler for the moment because I don't need that return at the end. All right, so I'm gonna run with this. I think it's justifiable to have a bool return type here, but I'm just not gonna do it. So now I gotta the place where we do lock. I want that. So and then although all we have to do otherwise is is basically make some other methods here. So public void unlock. So in this case, so if current does not equal door state dot lock, so if it's in the wrong state, return. And if passcode does not equal passcode, return. So those are, so now we have, in this case, we have two like early exits. If we were in the wrong state or the passcodes don't match, we bail. Otherwise, we're going to say current equals door state dot closed, but not locked. So now we can use that right here. And like I said, this is, so, no, closed, door state dot locked, unlock. What do you want to do? Unlock. So enter the password. Please enter the password. I'm actually gonna. Well, no, this should. Well, see, this should work. We didn't have a Boolean. This right here, this do while loop is looping. It just keeps looping until they enter in a valid password. So let's see. What I want is basically this right here. Door dot unlock passcode input. And I actually at this point, like this, I don't need to check that here. But what? So I've gone back and forth on whether these should be bool or void. This one should be turn false. If this one is a bool, then I actually would put that to use. So maybe it makes sense. Like maybe for symmetry, it isn't going to hurt anything to just make them all have a bool return type of whether it succeeded or not. And so in this case, I don't need to check this anymore. I can just, you give me the thing, and I can just say if it worked, if door to unlock, else let me do it this way. Let's see. So if correct password, let's see, correct password equals door to unlock. If not correct password, there's nothing like what was here is fine. I'm doing little changes that I think and I kind of like this console, this output and this output to be symmetric. So I kind of want to say if correct password up here, because I almost didn't realize that was down there. So having them be more closer together and symmetric might make it a little easier to maintain. Probably not that different, but there. So now it's like if else. So depending on if it was the correct password, what is this suggesting? I know it's suggesting that I don't need to initialize it there because either way it gets assigned here. But what's it? Okay, I guess that went away now. All right, so the only other ones I have left, and these are both very simple, would be So I got lock and unlock. I just need to open and close. So public bool open if current does not equal door state dot closed, return false. Current equals door state dot opened, return true. Like bool close if current does not equal door state dot opened, return false. Current equals door state dot closed, return true. And then use those methods up in here. Door dot close, and right here door dot open. And now I think we can, there's a few of these that we can clean up. Yeah, this could be made private. So now I can do private set. So now, and this was what I was going for here. Private is nobody knows, like you can't just change the current state. If you want to change it, you must call one of these other methods. So now with these methods, it can enforce the logic around its own state, and that is a very useful thing. Okay, this says I can make the whole thing private. I'm not going to do that. I'm going to convert it to a field. Do I? Like I just want to do private string passcode. So I had it this way at one point, and then I changed it away from that, and now we're back. I don't think this is used anymore. It says it's not. So I'm just, because of the paradigm that I imagined was that like you could change the passcode. Like the passcode would be persistent and it would just stay that way forever until you change it. So you could like lock it with a passcode, unlock it with the passcode. The paradigm that this person used, there's honestly a lot that I like about it. Like I said, I'd imagine it as the safe in a hotel room. Yeah. So at this point, I think we've turned our door class into something that is like I like this structure. I should probably say that it's fine that it's fine. Like different doesn't mean worse, right? Like just because the code used to look a particular way doesn't mean that it's bad in its, that it was bad. And just because I had an itch to change it doesn't mean that it's any better. But like I said, because no matter what you do, there's pros and cons to any of these choices, and so you have to stop and think about like what are the benefits of this structure. Well, first of all, you have to stop and think, how can I approach this? Well, so now we've talked about two different solutions. One of them is just have a public property for the current state, and you can get and set it however you want. And this alternative approach has, like, you can't just change it. You have all these methods. And so let's talk through the pros and cons. The downside to what I now have is, honestly, this is more code. It straight up is more code. Like I have 1, 2, 3, 4 methods that didn't exist before. There's a few things that are in this that weren't here before. Like this passcode string didn't used to be here, but it, like, this variable existed. It was just a local variable up farther. So like I'm not counting that against me, but in truth, like all of this is much more involved, right? Like there's a lot more code. So that's a downside to this. More code is, despite being somebody who writes code, you, me, despite being a programmer, it's important to keep in mind that code is a liability. It is the cost that we pay. Not unlike a painter's ink and canvases. Like, it's the medium that we use, and it, like, every line of code that we have is a line of code that might have a bug in it. It's a line of code that might need to be changed down the line. It's a line of code that a new person needs to understand at some point in order to really understand the whole program. It's this is every line of code you write is a cost. However, this is the most interesting part about software engineering to me, is that it's kind of rare to have something that, like, doesn't have some sort of downside, some sort of cost to it. There's a lot of qualities to code that make it good. And oftentimes they're competing. And an example of this is very often security and usability, like the user experience, like how the user interacts with it, are compete with each other. Having to sign in to a thing is a security, like, it makes it more secure. Like, not just anybody can see it, but it's a very obvious user experience problem. Is now I have to, like, remember this password. How am I going to remember this? I'll Google remember it, or like whatever it is. Like, it comes with a very real cost to the user experience. So if we skip the password, then we'd have better user experience. In exchange, we would have worse security. So very often the qualities that make software, our program, good, are in direct competition with each other. And we have to weigh the trade-offs and pick which set of benefits outweigh the costs of that. And sometimes you can find a solution that's like, hey, this is good user experience and good security. And maybe that's like my phone will be like, oh, unlocked by face recognition. Like, it'll say that a bunch. Like, I don't have to remember a code. I don't have to put it in. Like, the user experience is better. But now there's like a privacy concern, is like my camera's like, my phone is like watching me. What else is it doing, right? Like, there's like a privacy concern. Like, it's all these trade-offs, and we as engineers have the right and the responsibility to figure out, like, among the trade-offs, what do we do? So in this case, this is just another example of those trade-offs. I absolutely have more code. That's the downside here. The upshot compared to the other approach is that now you can't do things with the door that shouldn't be done with the door. So let me give an example of this. So I'm gonna, like, there's all this main method here, right? I'm gonna do something really crazy, and how well is this gonna work? Comment that. Poof. Okay, good. I got it all. I'm just gonna make public static void main another main method. And I'm just going to say door equals new door. Oh, by the way, at this point, like, maybe it doesn't, I don't know. Like, maybe it, like, if we're going to run with the safe in a hotel room analogy, we should just always initialize every door to closed without a passcode. So I had added in that passcode parameter. It kind of, I don't know if that makes sense anymore, but we'll leave it. We'll do that for now. Anyway, at this point now, like, me as a programmer, I can't just I can't, if I, like, try and access that passcode, it doesn't compile, right? So it exists. It's right there. In fact, when I control clicked on it, it took me right to it. But, like, this code doesn't compile. Now, I do want to say, like, I'm using this passcode. And I'm saying, look, you can't just set the passcode. I should point out that making something private is not a security mechanism. Like, if you don't want that, like, because there are ways around that. This is not about security. It's about making it so that programmers don't accidentally do the wrong thing, that the right thing is easy and the wrong thing is hard. It helps me now as a consumer of the door class, as a user of the door class, a client of the door class. I can like the design of the class helps me use it correctly and not misuse it. Um, what I had, the old version, I could have done something like door dot door dot it was current equals door state dot opened, and then I could do door dot current equals door state dot locked. So like it gave me this ability to just jump straight from locked to opened or open to locked, even though we kind of said that wasn't supposed to happen. It also gave me the ability to lock it without supplying a passcode, which in this case wasn't the intent. It also prevents me, like the old code had that, it was just a local variable, but I had the ability to just like reach in and grab that information that was meant to be kind of, like I said, in this case, like passcodes you would think should be like a secret, and it probably should be, but in this case we're talking about design, not security, and so I'm not worried about like that. But just like this stuff is like, no, this is data that the object itself is like saying, look, this is data I need. It's private data. You shouldn't be messing with that. There are other ways to manipulate this object. So these things that I used to be able to do, I no longer can. The design of the class kind of pushes me, the user of the class, down a particular pattern for using it. So now if I want to do some of this stuff, like I can't just set the passcode directly. If I want to set a passcode, I have to lock it, and I have to give it the passcode. So, and then I can say door.unlock. And we could do that to make sure that we actually did it. Run this really quick. So lock with a ABC, unlock ABC. And in this case now, I'm actually leveraging those Boolean return values. So anyway, this design for the class allows me to have a door class that is able to protect its own data. In fact, it has all the data that it needs, which includes the passcode. And that was like the original version. The passcode was just kind of floating loose. And if we had made multiple doors, like if we had done something like, door 2 equals new door, and so like this is door state dot locked, and with a passcode of something else, like this allows me to just, now I have a second door, or like I can add as many doors in here as I want, right? So this approach gives me the wiggle room to like, it now contains all the data related to the door, and it protects us data from manipulation that doesn't make sense in the context of the application. And so I think that that is a win. Now, one thing that it doesn't do is, and this gets back to what I was saying at the very beginning of this, the main method here, like what we used to have, let me uncomment this. Like there is still a lot of stuff going on in this main method that is about user input. It's all this stuff of like I gotta talk to the user, give them some options, allow them to pick an option, and then decide like what to do based on what they chose. If they chose a 1, then do this. If they chose a 2, then do this. And so all of this like user interaction is all here in the main method. And as I've said, the So that keeps that choice of putting that there keeps it out of the door class. So now, because the user input, the other thing that I often see people do on this challenge is put the user input inside the door class itself. It just as a really simple example to just like they might on this lock, rather than pass in the passcode, they might just do like a console.writeLine, enter the passcode, like string passcode equals console.readLine. Like they might get that, inject the user input in here, which again, it can be right. But what I like about this, because the user input is separated, I'm able to use this door class in more diverse ways. For example, I could have this door class on the server that isn't going to interact with the user, and that there's just some other network thing that's communicating with the client that is sending over this. So the passcode, the request of what to do is not console based, it's network based. Or maybe it gives me the option to do what I had done here a moment ago and just write a main method that just creates a new door and just programmatically does it. It's just hard coded C# code. So I have that ability with this particular door class. Or you could have an AI player that's interacting with it. So because the user input is separated from this door class, the door class can be used in places where user input happens in different ways. Like the way that you manage the door is done in different ways. I said 20 minutes on this and I'm at like 46 minutes. So I'm going to stop, but I do, like I said, I've seen a bunch of these the door solutions that put too much in the door class and plenty that do too little. Again, that's my opinion. Like I think that it's too much and too little. The reality here, to just kind of wrap this up, the reality is that at the place that we're at, none of those things that I said really matter. Everything that I just talked about, things like you might use this with network input, with AI, a computer controlled, like a non-player character, or whatever it is. Like there's other ways you can interact with it. This challenge does not require that. Similarly, like all this stuff where I moved the code here into the door class to allow the door class to protect its own data. It just isn't being used in a situation where a programmer, is going to get it wrong. Like it's short-lived. At this point, the original author is done with this, and I'm done with it now too. So it doesn't those concerns of what if somebody uses it wrong? They don't matter today. So all at a practical level, all of these designs are, I think, correct, good enough. Like I said, that this cost that I mentioned here, this is more code, and having these be bools is also more code to convey information back to the caller. But anyway, it's those are hypothetical situations that in fact they're not just what if it does that in the future. Like we know we're not going to do that in the future. We know that this code is very short-lived. We're done with it. The only reason it's worth talking about and thinking about is we want to get the exposure and the experience of dealing with classes and object-oriented design on small problems so that we know what we're doing so that it isn't so complicated and wild when we need to, when the program is big, when we're dealing with a project that takes 3 months to do and that there's 4 people working on, and that we do need to worry about these things. So this is good practice for that. But as I said, it's food for thought, things to consider, a different take on it. And hopefully some of my walking through it step by step was useful as well. But like I said, they're from a purely objective standpoint, this is no better. In fact, you could make an argument that it's more code, so therefore it's worse than what I had, because the things that it's trying to account for are kind of future-proofing it in something that really has no future. But like I said, that's justified by this is good practice for when those things do matter, or it's good habits to ingrain for the times where you do need that. Everything in part 2 is really about how do we, especially objects, but it's about how do we build big programs that can be changed and evolved over time, that are, even though they're really complicated, that we can still understand them, even when they're 10,000 or 10 million lines of code long. So this type of stuff of like making it so that you are kind of forced into the correct usage goes a long way when you have a 10,000 line program instead of a, how long is this right now? 138 line program. All right, I'm going to sign off for now. So thanks for joining me here, and I'll see you guys next time.